Okay, welcome to this next video. My name is Mr. Parr and I'm going to be going through how we find the gradient of a linear graph. Before we can do that, some very simple skills you need to have mastered: division and understanding the coordinates of a set of axes. If you've got those, finding a gradient should be nice and easy for you. So, here I've got two graphs, both with a set of axes, obviously with your x and your y, and for the purpose of this video I'm making it so that each square is worth 1, so that would be 1, 2, 3, and then obviously then going down this way you'd be going into negative values. Now for those of you who don't know what gradient is, more importantly, gradient is a numerical measure for the steepness of a line. So if gradient equals steepness, we need to calculate that numerical value. Now we get that numerical value by doing a calculation that we call the difference in y divided by the difference in x. Some people prefer to think of this as the rise over the run, just to keep it simpler if you'd rather. And the way we find those is actually pretty simple. We find that by picking just 2 points on our graph line. So I'm going to pick 2 random points. Now, ideally, you want to try and pick points that are on whole number values from your grid. So, for instance, if I chose this point here, you can see that it hits on whole number values. So that would be -1, -2, -3, -4. And that would be -1, -2, -4. Nice and easy numbers. So I've got that point. Then I pick another one somewhere. I'm going to go for this one. And that's at 2, 2. And now with that, what I can do is I can create a right angled triangle. Now, the reason we do this is our rise and our run. This is the run, so run along and rise. And we can easily get these values just by counting along. So 1, 2, 3, 4, 5, 6. So the gradient of this one would be 6 for our run, that should be 6 for our run, and our rise 1, 2, 3, 4, 5, 6. And 6 divided by 6, as you know, is 1. So that means this graph has a gradient of 1. Done. Now here, I've got another line going through a different point this time. It's going through the middle. But again, I'm just going to pick 2 random points that have whole number values. So I'm going to pick this point. And, let's stick with that point. Why not? We've already got a point. So this point here is at there, and we've got another one out here, so let's count it out. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that has a, as we said before, remember it's rise over run, or dy over dx for those. This is worth memorising for those of you aiming, you think you're going to want to do A-level maths. This comes up a lot, dy over dx, so it's worth knowing that as well. And as we just worked out, it was 5 as a rise, 5 as a run. Again, gradient of 1. So even though this graph is in a different position, this one went through the origin. This one went through at value, or at height 1, should we say. It still has the same gradient. Now this tells us something else really pretty cool actually. Because they have the same gradient, I know that if I was to pick up this line and to move it, they are in fact the same line, just in different positions. So that tells us something actually about this graph, and what it tells us is that they're parallel lines. That if I was to draw this on that axis up here, on the top axis, that these two lines would be parallel because they have the same gradient. That's worth remembering that, because later on you'll be learning how to prove in other lessons or videos that I'll do that two lines are parallel. So it's worth remembering that these two lines are now parallel. Right, moving on. So here's some more examples I was going to quickly go through. And again, I'm going to do the same thing on each one. So I'm going to calculate the gradient, which is dy over dx. And we do that by, again, just picking 2 points that have whole number values. Much easier if we can do that. If you can't, it's still doable, but it's tricky. But let's go for these. So I'm going to go for that point there and that point there. They seem to have a nice set whole number values. So again, for the purpose of this, I'm doing grids where each square is worth 1. So 1, 2. So my change in x, or my run, is 2. My rise is 4. 4 divided by 2 is 2. There we are. So my gradient of this graph is 2. Next one. Pick 2 points. There's a point. If I go along, where's another one? Oh, there's another one. So this one has a run of 2. If I go straight up, sorry for the wiggly line. 1, 2, 3, 4, 5, 6, and a rise of 6. So 6 over 2. So this one has a gradient of 3. Done. Pick another one over here. So I'm going to do the bottom left one now. So let's pick a point there. I mean, it doesn't matter how far apart you do them. I can go all the way down here. It just makes my life a bit more tricky, because now I've got this massive triangle which just involves a lot more counting. So rise over run again, if you want to remember it that way. 1, 2, 3. Oops, sorry. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, be careful here, because whilst we say, you could say that the run is 6, this isn't really a rise anymore, is it? Because if I was to put 12 here, that would give me an answer of 2 again, because 12 divided by 6 is 2. But how can this graph have the same gradient as this graph when you can see, remember we read graphs from left to right, that this graph is going upwards and this graph is going downwards. So how can I differentiate between them? Well, the way we do that, now your run will always be positive, because if you think about it, the values over here are negative. The values over here are positive. So as you go left to right, your x values are going up. They're increasing, hence why that's positive. But if you think about from here to here, you're actually going down. Your y values are decreasing. So for every step I go down, I'm actually doing that. I'm going down. I'm going in a negative direction. So this should be minus 12 this time. Now, negatives with positives, negative 12 divided by positive 6 gives us negative 2. So this graph, because it's going downwards, has a negative gradient. Now that helps us with the next one. If you memorise that, this next one immediately I know is going to have a negative gradient because it's going downwards as we travel from left to right through the graph. So again, let's do our rise. Oops. Over run. So we're going to need our triangle again. So let's pick 2 random points. I'm going to pick this point here, and I'm going to pick this point here. Get my triangle there and there, which allows me to get my numbers again. So 1, 2, 3, 4 across, 1, 2, 3, 4 down. So remember it's decreasing, so minus 4. So my rise in this case is going to be a negative because it's going downwards, and my run is 4. Negative divided by positive is negative. 4 divided by 4 is 1. So this has a gradient of minus 1. And that's it. So remember, If the graph is going upwards, your rise is positive. If the graph is going downwards, your rise is negative, because technically you could argue if it's going downwards, it's not actually rising, it's falling. So if rising is positive, falling must be negative. Now, if we move on from this, I've now got here for you 4 questions for you to have a go at. You can try and do it on the screen. It should be doable. If you've got square paper, you could draw them out, but give them a go. Pause the video whilst you're doing that, and when you're ready to go through the answers, press play again, and I'll go through the answers with you. Okay, so now you've had a go at these, let's quickly go through the answers. I'm going to do this a bit faster than I have on the other ones, with a little bit less explanation, and just write it out. So there's my markings, and it's just a matter of counting now. Rise over run. So 1, 2, 3, 4 across. There's my run. 1, 2, 3, 4, 5, 6, 7. Is that right? 1, 2, 3, 4, 5, 6, 7. So that's 7 over 4. Oh, horrible number. So if I wanted to, I can now go to my calculator, which is over here, and do 7 divided by 4, which gives us a gradient of 1.75. Done. There's my gradient. Next one, pick 2 points. There and there. So I'm making a nice small triangle this time. So rise is 1, run is 3, which we can see is a third, so hopefully you know that as a decimal is 0.3 recurring. Now you can leave, if you want to, a gradient as a fraction. 1/3 as a gradient is okay. You don't have to convert to a decimal. In fact, I'd probably leave it like this, because a third is a recurring decimal. So it's easier to write as a fraction. So I'd go with that as my answer. But both are acceptable. They're both correct. They're both okay to have. But mathematicians, we prefer fractions instead of recurring decimals. Right, next one. So pick 2 points. I've picked this one and that one. Now, regardless which points you pick, you should be getting the same gradient as me, because it's a straight line. So 2 across. 1, 2, 3, 4, 5, 6 down. So my rise, so this is negative. So it's a negative 6 over 2, which gives me a gradient of -3. And the next one, again, 2 random points there, and let's say there, which is 3 across and 3 down. So again, rise over run, -1. Done. And there's my gradient. So for those of you who don't believe me, it shouldn't matter which points you pick. If I pick another 2 random points on one of these graphs, so this one here, and let's say this one down here, if I go out, that's 3 out, 1, 2, 3, 4, 5, 6, 7, 8, 9 down, so -9. So that becomes -9 over 3, which is still -3. Same answer. So it doesn't matter which 2 points you pick. You will always get the same gradient. Don't worry about the points. I could do it on, I could do it on this one as well. There we are. Those 2 points there. That's a rise of 2, a run of 1, 2, 3, 4, 5. Hang on, have I read that right? One, two, three. What's happened here? Why has that stopped working? Have I drawn a bad graph? So it goes cross 3 up 1, cross 3 up 1, cross 3 up 1, cross 3 up 1. That should work. So what have I done wrong? 1, 2, 3. I miscounted. That's why. And 2. There we are. So a 2 and a 6. I miscounted. Right. So yes, that should be a rise of 2 over a run of 6, which you can see is 2/6. which does simplify to 1/3. There we go. That works. So we've still got that same gradient of 1/3 as we did up here. Doesn't matter. Apologies. I counted, misread the graph across, and that's what made it go a little bit wrong. That's why you should always double check. If you're not sure if your gradient's right, you could always pick another 2 points and try it again. So I hope this has helped. If you do need anything in future, please let me know. I'm always willing to make videos if I've got the time to help people out. And thanks for watching. Bye.